we go to a company that wants to do automated machining for large field of view and high CRA lens testing. We go to Phasics, and with us we have Nolan Chang, who is the key account manager at Phasics, and who is going to tell us how the other 750 members can benefit by the market leadership on testing based away from sensors from Phasics. The floor is yours.
Thank you for the introduction, Jose. So today I will present Kaleo MTF, actually the new version of Kaleo MTF, which is our automated machine for high CRA lens testing. But before that, I will go over with a couple words about Phasics. So Phasics is a French company that was established in 2003 for about 40 employees. And our main focus is designing, manufacturing, and supplying high-resolution wavefront measurement equipment from deep UV, so 190 nanometers, to 14 microns. All our products, our main products, are based on one technology that is called quadri-wave lateral shearing interferometry, which is a specific wavefront measurement technique. So here we have an example, actually a quick overview of the different products we have. So we start with the core of all our products, which is the wavefront sensor and the wavefront sensor technology. And we have two examples here. One is a visible wavefront sensor with high resolution, and another one that is specific to microscopy imaging, and that actually we can use a lot for meta lens characterization. Just to give you an idea, our typical products, we can reach up to like 800 times 700 measurement points on the phase mount. To make a measurement, we also developed accessories to couple with the wavefront sensors, like we have here, which is a R-Cube illumination module, so that we can provide everything from the wavefront sensor to the source to have a high quality beam that can go through your optics, and then we use our sensors to analyze what is transmitted. We also have, and the next step, so more and more integration, a lot of different accessories to couple with these two elements, like we can see here, a wavefront sensor, the R-Cube module, optomechanics, and then different optics to shape typically the beam that goes out of the R-Cube. It can be converging, diverging, or really large and high quality collimated beam. And if you want to go to even more integration, we have turnkey solutions, so completely automatic machines, like here, Kaleo Multi-Wave, which is an interferometer-like system. So it is used like a piezo. It can be used with the accessories of a piezo interferometer, but it has the versatility of wavefront sensors. So in terms of wavelengths, so you can have up to 8 different wavelengths inside. And you can also have large dynamic range that is typically one of the specificities of the wavefront sensors. And what I will focus on today is actually Kaleo MTF, which looks like that, and also like that in total, in the full size. So the idea of Kaleo MTF is to characterize objective lenses, so imaging optics automatically. So what kind of optics do we measure? So they're actually quite small, and you can see the actual scale here. So it can be either smartphone lenses, automotive lenses for autonomous cars. It can also be meta lenses or more specific lenses. So the idea is really for us to measure high-end and high-performance lenses, because typically what we have now, and as it was mentioned just a few minutes ago, the devices are going really smaller, and smaller means that you have more CRAs, like higher angles to aim for the edges of the sensor. You have high NA for more resolution and more pixels to have better images. You have a wider field of view to see more with less devices. And something that also comes with that, and that has been quite a headache for the recent developments, is we have nonlinear CRA evolution, distortion, etc. across the field that can be hard to measure. And we really focused our development on these really hard to measure lenses. But what do we do exactly for these lenses? So we measure, of course, for up to 8 different wavelengths from in the visible and the near infrared, the different parameters that are, of course, the OPD, which is directly the wavefront information, the optical aberrations, the MTF, which is the imaging quality, some geometric parameters like EFL, F number, field curvature, etc. And the idea of the whole system is to give as much information as you can with a single machine and a single measurement. So the specificities of our machine is really to have a fast and fully automated measurement process, a quick setup with no alignment. You simply need to place the sample inside and you would have all the measurement. You can customize the measurement sequence. You can choose the wavelengths, the angles, the azimuths that you want. All the results are basically in wavefront, and we can change the plane where we analyze the wavefront, so you can really compare to the design that you have. And we, of course, have accurate and reproducible measurements. So as I mentioned, we aim for really high-end and high-performance lenses. So these are typically used in the automotive, smartphone, augmented and virtual reality. We also aim later on for drone and surveillance applications. So to end this presentation, of course, if you have any questions, don't hesitate. I'll be glad to answer it. We also plan to have a demonstration of Kaleo MTF that will be coming in the form of a webinar. So don't hesitate to contact us by email or through our website to register.
Thank you very much. Contact at Phasics.fr. Contact them there. This is one of the key companies to watch. I have some questions for you, but you get the first question for me, which is the epic question. What can you do for them and what can they do for you?
So, of course, for the other members, we would be glad to collaborate and to actually discover what kind of hard challenges they have and what kind of metrology issues they can encounter. And for us, as we are developing new solutions all the time, we'd be glad to have some samples or some maybe things that can be shared and for which they would like to know if it's measurable, because that's actually quite a common issue in innovation, that you develop things that you cannot measure and that you cannot control. And we're also working on that, on how to measure these particular things.